Hello and welcome friends. In this video we discuss about integrability of a function depending on a Riemann sum. Friends, we have seen that the upper sum and lower sum, when the function is integrable, then the upper sum minus lower sum is less than epsilon. The definition of upper sum contains supremum of the function in the subinterval delta xi into the length of subinterval and summation of all such, and lower sum is the infimum of the value of the function in that subinterval. Is about UPF, means m1 into delta x1 plus m2 into delta x2 plus mn into delta xn, and lower sum is small m1 into delta x1 plus small m2 into delta x2 plus small mn into delta xn. What is my capital M? Capital Mi is the supremum of f of x, value of f of x, where x belongs to the interval xi minus 1 to xi. Okay, and what is my small m I? Small mi is infimum of f of x, value of the function f of x. X belongs to the closed interval xi minus 1 to xi. Let us take an example. I have already mentioned this, I have already taken this, but here this is we will see what is the difference between the upper sum, lower sum and a Riemann sum. Suppose our function is that f of x equal to x square and interval is 1 to 2. Then the value of the function f of 1 equal to 1 square, that is 1, f of 2 equal to 2 square, that is 4, and all the values of f of x lies between 1 and 4. All values of f of x is lies between 1 and 4, and 4 is the maximum value of this function. So this is our capital M and this is our small m for this interval 1 to 2. But you can see that there are number of points between 1 and 2. Now instead of this supremum and infimum, if we take f of t1 into delta x1, what is this t1? T1 is any point in the subinterval x0 comma x1. So it varies from x0 to x1. For this interval 1 to 2, there are infinite points and infinite choice of the points t1 between the interval 1 to 2. So this t1, we can take this t1 as a capital M, which is nothing but this f of t1, this t1 which is not t1 equal to capital M, for which we get capital M, and we can take this t1 equal to 1, for where we get a small m value. But here the capital M and small m are the supremum and infimum of the function value, and in this case we there are these, we have chosen these points between 1 and 2. So likewise, if we take another points in the another interval delta x2 plus f of tn into delta xn, and this sum is differ from this sum, okay, and that is why we call it as a supremum, SPF, and it is nothing but a Riemann sum. Okay, see the difference between these two. These are the two fixed values of the interval, subinterval capital M1 and small m1, if once we have decided what is our delta x1. but here there is a choice f of t1. T1 is any point in the delta x1, and whenever limit, if we take the limit of this SPF where this mu of p tends to 0. What is mu of p? That is a maximum length of the interval tends to 0. If this limit it exists, let us call it as a, and we denote this as a summation of f of ti into delta xi. I varies from 1 to n. Then this is called as a integration, Riemann integration of this function. So this is the basic difference between the upper sum, lower sum and a Riemann sum. Riemann have chosen any points between the subintervals. So there is a possibility, we have number of possibilities of to choose the points t1. Hence, whenever the limit of this SPF Riemann sum exists as mu of p tends to 0, then this is called as a Riemann sum, and the integration, whenever the limit exists, it is called as an integration of the function. We write the same thing as in terms of, as it is a limit, there is a limit depending on the definition of limit. For every epsilon greater than 0 there exists delta greater than 0 whenever such that this f of ti into delta xi I equal to 1 to n minus a is less than epsilon whenever this mu of p is less than delta. If this condition is satisfied, then the function is said to be Riemann integrable. Here in this case, when we are talking about the Riemann sum. Now we see how these two definitions of integrations are equivalent. The definition depending on the upper sum, lower sum, and the definition depending on the Riemann sum. We know that the function is a integrable whenever upper integral equal to lower integral, whenever upper integral of the function is equal to lower integral of the function. But we know that by Darboux theorem, for epsilon greater than 0 there exists a partition P of a and b, x0 is equal to b up to xn is equal to b, such that the upper sum UPF is less than upper integral f dx plus 1 by 2 epsilon. Whenever this condition is satisfied by Darboux theorem, then again what is the lower sum? Lower sum by Darboux condition, lower sum is greater than lower integral minus 1 by 2 epsilon, but function is an integrable function, so upper sum is less than integration of f plus 1 by 2 epsilon, and lower sum is greater than a to b f dx minus 1 by 2 epsilon. We have taken first the upper sum, and function is an integrable by definition depending on upper sum and lower sum. Then we have the lower sum, the upper sum UPF. UPF is a less than equal to summation of f of ti into delta xi is less than equal to UPF. As just I have told you, we have taken the function where the maximum value of this function x square for the interval 1 to 2, where the value of maximum value is 4, minimum value is 1. So all the values of the f of x lies between 1 and 4. This is a low infimum. So infimum value is LPF is here. If we take the summation, then this is summation of f of ti into delta xi, and this is nothing but UPF. Okay. So this is small m and this is capital M. That means all the values of function lies between small m and capital M, and therefore this sum is lies between f of ti into delta xi lies between upper sum minus lower sum. Okay, then friends, we have this value LPF. But what is a LPF? LPF is greater than integration of f between a to b minus 1 by 2 epsilon is less than summation of f of ti into delta xi, and UPF is less than integration of f between this integration of f plus 1 by 2 epsilon. Then see here, this inequality is nothing but modulus of f of ti into delta xi minus integration of f is less than epsilon. So this shows that this function is reintegrable by definition of, according to the definition of Riemann sum. This is as per the definition of Riemann sum, where we have considered the function is integrable as per the definition of upper sum and lower sum, and we have proved that the function is integrable as per the definition of Riemann sum. Now converse part, now we see that if the function is integrable as per the definition of Riemann sum, then what about the integrability of the function as per upper integral and lower integral? So according to the Riemann sum, summation of f of ti into delta xi minus a is less than epsilon. Then obviously this function is a bounded function, and the function is bounded, therefore for epsilon is equal to 1 mod of f of ti into delta xi is less than, we can write this inequality as mod a plus epsilon, which is 1. Okay, for this value there exists an delta greater than 0 such that the partition p with norm mu of p less than delta. Okay, by definition, for epsilon greater than 0 there exists delta greater than 0 such that for mu of p less than delta, mod of f of ti into delta xi is less than mod a plus epsilon. Okay, we can write this. If as possible the function is not bounded, then if function is not bounded, there exists some interval delta xm such that we can choose a point from this interval delta xm which is different from these all points ti. Okay, I is not equal to m, I from all other intervals, right? Then what we get, this summation of f of, it is possible that summation of f of x, f of tm into delta xm is greater than mod a plus 1, as the function is not bounded. If it is not bounded, there is a possibility that there are some values for which the function is greater than the mod a plus 1. Okay, but this is a contradiction to this one here, this condition, this is for all values of the function, and this is a possibility. If possible the function is not bounded, somewhere is not bounded, then we get that this value of this function is greater than mod a plus 1. So this shows that f is bounded. Okay, now as f is bounded, we can write this inequality by using the modulus property as a minus 1 by 2 is less than summation of ti into delta xi is less than a plus 1 by 2 epsilon. This is for all values of epsilon, so we can take 1 by 2 epsilon. But we know that a minus 1 by 2 epsilon is less than equal to here LPF. We know that LPF is less than equal to summation of f of ti into delta xi, and this is less than equal to UPF, and this is less than a plus 1 by 2 epsilon. Okay, So this is an arbitrary bounds of these functions, all of these values, and these values UPF and LPF are near to the summation of delta xi, and therefore we have that LPF and UPF lies between these values. But then what we get, UPF minus LPF, UPF minus LPF is less than A plus 1 by 2 epsilon minus A plus 1 by 2 epsilon. Subtraction, A get cancel, and this is less than epsilon. So here UPF minus, by the condition of integrability, the function is integrable. Okay, upper sum minus lower sum is less than epsilon, and hence this function is an integrable. So friend, we have shown that whenever the function is integrable by the first definition, that means as per the definition of upper sum and lower sum, the function is integrable as per the definition of Riemann sum. Whenever the function is integrable as per the definition of Riemann sum, the function is integrable as per the definition. We have proved it is integrable according to the definition of upper sum and Riemann sum. So this is the main point which gives us a new definition of integrability of the functions.